You have made it to part 9. One part left after this one. In parts 1 through 8, you built the knowledge. In part 9, we break it. Every single question in this video is designed around a deliberate trap. A word in the scenario that sounds like it points to one answer, but actually points to another. A number that looks like a regression output, but is actually a classification label. A translation requirement that sounds like a speech task, but is actually a text task. These are the questions that separate candidates who pass from candidates who almost pass. 10 edge case questions, each built around a single pivot point. If you can spot the pivot before you look at the options, you'll get the question right. Let's find out how many pivots you can catch. Welcome back to our channel. Part 9 of 10. The final part, the full timed exam simulation, drops next. Subscribe and hit the bell right now so part 10 lands in your feed the moment it is live. Now, no warm-up. Let's get straight into the edge cases. Before we start, here is the exam pivot framework you need for part 9. Exam edge case questions work by making one answer look obviously correct while hiding the correct answer behind a single word or concept distinction. There are 5 pivot patterns that appear most frequently. First, any output that is a number from a fixed discrete set is classification, not regression, even if the numbers are 1 through 5. Second, translation of spoken audio is Azure AI speech. Translation of written text is Azure Translator. The word spoken is the pivot. Third, when 2 responsible AI principles are both plausible, ask yourself, is the issue that the decision cannot be explained, which equals transparency, or that no human is accepting responsibility, which equals accountability? Fourth, high overall accuracy that hides poor subgroup performance is a fairness risk, not just a reliability risk. Fifth, if the output categories are custom labels such as urgent or critical, that is text classification. If the output is positive, negative, or neutral, that is sentiment analysis. Spot the pivot, and the answer follows. Let's go. Question 1 of 10. A data science team builds 2 models. The first model predicts whether a patient will be readmitted to hospital within 30 days of discharge, returning either yes or no. The second model predicts the exact number of days until a patient is likely to be readmitted. A colleague argues that both models are classification models because they both involve patient readmission. Is the colleague correct, and why? Option A. Yes, both are classification models because they both predict an outcome related to readmission. Option B. No. The first is a classification model and the second is a regression model because the first predicts a discrete label and the second predicts a continuous number. Option C. No. Both are regression models because they both predict future patient outcomes based on historical data. Option D. Yes, both are classification models because both use the same input features. Take careful note of what each model actually outputs. The correct answer is B. The colleague is incorrect. The output type is what determines the model type, not the subject matter or the input features. The first model predicts a discrete binary label, yes or no, which makes it a classification model. The second model predicts an exact number of days, which is a continuous numerical value, making it a regression model. 2 models on the same topic can be fundamentally different types depending solely on what they output. The exam frequently embeds this trap by using the same real-world subject for both model descriptions. Key trigger: yes or no, pass or fail, spam or not spam equals classification. Exact number, amount, price, or duration equals regression. Question 2 of 10. 2 scenarios involve binary classification models with imperfect performance. Scenario 1. A spam email filter that occasionally marks legitimate emails as spam, causing important messages to be missed by the recipient. Scenario 2. A cancer screening model that occasionally classifies a cancer scan as normal, meaning a patient with cancer is told they are clear. In which scenario is recall the more critical metric to optimize and why? Option A. Scenario 1. Because missing a spam email is more harmful than incorrectly flagging a legitimate email. Option B. Both scenarios require precision to be optimized because both involve false positives. Option C, Scenario 2, because the cost of a false negative, missing a real cancer case, is far higher than the cost of a false positive, and recall measures how well the model captures all actual positive cases. Option D, Scenario 1, because email filtering affects more people than cancer screening. Read this carefully and think about what precision and recall each measure. The correct answer is C. Recall measures the proportion of actual positive cases that the model correctly identifies. In Scenario 2, a false negative means a real cancer patient is told they are healthy, which could be fatal if treatment is delayed. When the cost of missing a true positive is extremely high, recall must be prioritized over precision. Precision measures the proportion of predicted positives that are actually positive. In Scenario 1, marking a legitimate email as spam is a false positive, and the cost is inconvenience, not a life-threatening misdiagnosis. Scenario 1 calls for optimizing precision to reduce false positives. Option B is wrong because it conflates both scenarios with precision. Key trigger: high cost of missing a real positive case, such as disease, fraud, or structural failure, equals recall is the critical metric. Question 3 of 10. A conference organizer has 2 requirements. The first is to provide real-time subtitles on screen during presentations given in French by transcribing the spoken French audio and displaying the words in English text. The second is to translate a printed conference program written in Japanese into English so it can be distributed to international attendees. A developer suggests using Azure Translator for both requirements. Is the developer correct? Option A, yes. Azure Translator handles both spoken and written language translation. Option B, no. Azure AI Speech with speech translation should be used for the first requirement, and Azure Translator should be used for the second. Option C, no. Azure Translator should be used for the first requirement, and Azure AI Speech Text-to-Speech should be used for the second. Option D, yes. Azure AI Speech handles both requirements because both involve French and Japanese. Think carefully about what each requirement's input format actually is. The correct answer is B. The developer is incorrect for the first requirement. The first requirement involves spoken French audio that must be converted and translated in real time for on-screen English subtitles. This requires Azure AI Speech with its speech translation capability, which transcribes spoken language and translates it simultaneously. Azure Translator is designed for written text input, not live audio. The second requirement involves a printed document in Japanese that needs to be translated into written English. That is exactly what Azure Translator is designed for. The critical edge in this question is the word spoken in requirement 1. The moment the input is audio, Azure Translator is not the right service. Key trigger: translating live spoken audio equals Azure AI Speech Translation. Translating written text between languages equals Azure Translator. Question 4 of 10. An artificial intelligence model is deployed to assess driving test results. An internal audit produces 2 findings. Finding 1. The model's average accuracy across all test takers is 94%. Finding 2. The model's accuracy for candidates tested in wet weather conditions is only 58%, while its accuracy for candidates tested in dry conditions is 97%. A compliance officer argues that because the overall accuracy is 94%, only the reliability and safety principle needs to be reviewed, not the fairness principle, because the difference is driven by weather, not by a personal characteristic of the candidates. Is the compliance officer correct? Option A, yes, because weather conditions are an environmental factor, not a protected characteristic, so fairness is not applicable. Option B, yes, because the 94% overall accuracy is within acceptable limits, so neither principle requires review. Option C, no, the compliance officer is only partially correct. Reliability and safety is at risk because performance is inconsistent across conditions. However, if wet weather testing disproportionately affects candidates from regions with high rainfall, or if testing schedules systematically assign certain demographic groups to wet conditions, fairness may also be at risk and should be investigated. Option D, no. Only the fairness principle needs to be reviewed because differential accuracy across conditions is always a fairness issue. Read the question carefully before selecting. The correct answer is C. The compliance officer is only partially correct. Reliability and safety is clearly at risk because the model performs inconsistently depending on environmental conditions, which is a direct performance consistency failure. However, dismissing fairness entirely is premature. If wet weather testing conditions are not randomly distributed across candidates, and if certain demographic groups are disproportionately assigned to wet conditions, the performance gap could create a fairness issue. The compliance officer's reasoning contains a logical gap. The exam tests whether you can identify both the direct violation and the secondary risk that requires investigation. Key trigger: inconsistent performance across conditions equals reliability and safety. Investigating whether environmental factors correlate with demographic groups equals due diligence on fairness. Question 5 of 10. A developer describes 3 machine learning scenarios. Scenario 1. A model is trained to classify images of fruit as apple, orange, or banana using 10,000 labeled images. Scenario 2. A model is trained to predict the star rating, 1 to 5 stars, a customer will give a product, using a dataset of historical purchases where each row is labeled with the customer's actual star rating. Scenario 3. A model groups website users into behavioral segments based on clickstream data, with no labels provided. A colleague claims that Scenario 2 is a regression task because it predicts a number. Is the colleague correct? Option A, yes, because any task predicting a number is regression. Option B, no. Scenario 2 is a classification task because the output is a discrete star rating from a fixed set of 5 categories, not a continuous number. Option C, yes, because star ratings are numerical values and all numerical predictions are regression. Option D, no. Scenario 2 is a clustering task because it groups customers by behavior. Think carefully about the nature of the output in Scenario 2 before selecting. The correct answer is B. The colleague is incorrect. The key distinction is not whether the output is represented as a number, but whether that number is a value from a fixed discrete set or a continuous unbounded range. Star ratings from 1 to 5 are a fixed set of 5 discrete categories. Even though they are represented numerically, predicting which one of those 5 categories applies to a given customer is a classification task. Regression is appropriate when the output is a continuous numerical value such as a price, a temperature, or a measurement that can take any value along a scale. Scenario 1 is multi-class classification. Scenario 3 is unsupervised clustering. The trap is the assumption that any numerical output equals regression. Key trigger: output is one from a fixed set of discrete categories, even if numbered, equals classification. Output is any value along a continuous scale equals regression. Halfway through. Score out of 5, but more importantly, drop a comment telling me which pivot almost caught you out. Was it the star rating regression trap? The translation direction trap? That is exactly the kind of reflection that locks in exam performance. The second half escalates. Question 10 has 6 deliberately placed pivot traps in a single scenario. If you can name the pivot in each of the next 5 questions before you look at the options, you are operating at the level this exam rewards. Let's keep going. Question 6 of 10. 2 teams at a financial services firm both want to build chatbots. Team 1 consists of compliance managers and customer experience leads who have deep knowledge of the firm's products and policies, but have no software development skills. They need to build a bot to answer client frequently asked questions within 2 weeks without developer involvement. Team 2 consists of software developers who need to build a complex bot that integrates with the firm's core banking system via a custom API, handles multi-turn conditional dialogue logic, and connects to Azure Cognitive Search for document retrieval. Which tools should each team use? Option A, Power Virtual Agents for Team 1 and Bot Framework Composer or Azure Bot Service, with the SDK for Team 2. Option B, Bot Framework Composer for Team 1 and Power Virtual Agents for Team 2. Option C, Azure Machine Learning Designer for Team 1 and Bot Framework Composer for Team 2. Option D, Power Virtual Agents for both teams because it supports all bot scenarios. Think about the defining characteristics of each team before selecting. The correct answer is A. Team 1, no coding skills, business domain experts, tight timeline, self-service build, is the exact audience that Power Virtual Agents is designed for. It provides a no-code graphical topic authoring interface that business users can use without developer support. Team 2, developers requiring custom API integration, complex conditional dialogue, and Azure Cognitive Search connection, needs the full Bot Framework SDK or Bot Framework Composer, which provide the programmatic control and integration depth required. Option B reverses the assignments, giving Composer to the non-developers and Power Virtual Agents to the developers. Option D is wrong because Power Virtual Agents does not support custom API integrations or complex SDK-level dialogue logic at the depth Team 2 requires. Key trigger: no-code business user bot equals Power Virtual Agents. Developer-built bot with custom integrations equals Bot Framework SDK or Composer. Question 7 of 10. An artificial intelligence system is used by a university to make scholarship award decisions. Two separate issues arise. Issue 1. When a student asks why their scholarship application was rejected, the university's admissions office says they can see the model's decision but cannot explain the reasoning behind it in a way the student can understand. Issue 2. When a journalist investigates a pattern of rejections, the university president says the scholarship decisions are produced by the AI vendor's model and the university does not consider itself responsible for the outcomes. A student union representative argues that both issues are transparency violations. Is the student union representative correct? Option A, yes, both issues are transparency violations because the university cannot explain the reasoning in either case. Option B, no. Issue 1 is a transparency violation because the decision cannot be explained to the student. Issue 2 is an accountability violation because the university is deflecting its responsibility for a system it deployed. Option C, no. Both issues are accountability violations because the university is refusing to take ownership in both cases. Option D, no. Issue 1 is a fairness violation and Issue 2 is a transparency violation. Think very carefully about the precise definitions of transparency and accountability before selecting. The correct answer is B. The student union representative is incorrect about Issue 2. Issue 1 is a transparency violation. The transparency principle requires that the reasoning behind AI decisions can be understood and explained to the people affected by them. When the admissions office cannot explain why the student was rejected, transparency has failed. Issue 2 is an accountability violation, not a transparency violation. The accountability principle requires that the organization deploying an AI system remains responsible for its outcomes, regardless of whether the model was built in-house or by a third party. The university president's claim that the vendor is responsible is a direct accountability failure. The distinction is precise. Transparency is about whether the decision logic can be explained. Accountability is about whether the right human or organization owns responsibility for the decision. Key trigger: decision cannot be explained to the person affected equals transparency. Organization claims it is not responsible for its own deployed system equals accountability. Question 8 of 10. A legal firm has two digitization requirements. Requirement 1. Scan and extract all text from hundreds of historical court transcripts that are stored as scanned image files. The transcripts have no consistent format, and the firm simply needs all the text content made searchable. Requirement 2. Extract the specific fields of case number, presiding judge, defendant name, verdict, and sentencing date from thousands of structured court judgment forms, each of which follows a consistent layout. A developer proposes using Azure AI Document Intelligence for both requirements. Is the developer correct? Option A, yes. Azure AI Document Intelligence is the right tool for extracting text from all types of scanned documents. Option B, no. Azure AI Vision Optical Character Recognition should be used for Requirement 1, and Azure AI Document Intelligence should be used for Requirement 2. Option C, no. Azure AI Language Named Entity Recognition should be used for both requirements. Option D, no. Azure AI Document Intelligence should be used for Requirement 1, and Azure AI Vision Optical Character Recognition should be used for Requirement 2. Think about what distinguishes the two requirements at a structural level. The correct answer is B. The developer is incorrect about Requirement 1. Requirement 1 involves extracting unstructured text content from documents that have no consistent format. The firm simply wants all the text made searchable, which is the core job of optical character recognition, or OCR, available through Azure AI Vision. Applying Azure AI Document Intelligence to unformatted narrative transcripts adds unnecessary complexity with no benefit, because Document Intelligence is optimized for identifying and extracting specific named fields from documents with recognizable layout structure. Requirement 2. Extracting specific named fields from structured forms with a consistent layout is precisely the task Azure AI Document Intelligence is designed for. It understands a layout of the form and can reliably extract the correct value for each specific field. Key trigger: extract all text from unstructured documents equals OCR via Azure AI Vision. Extract specific named fields from structured forms equals Azure AI Document Intelligence. Question 9 of 10. A financial services company is exploring how to improve the accuracy and relevance of responses from a large language model used internally. 3 colleagues each suggest a different approach. Colleague 1 suggests writing more specific and detailed instructions in the input to guide the model's response style and scope without changing the underlying model. Colleague 2 suggests updating the model's weights by training it on the company's own proprietary financial documents to internalize domain-specific knowledge. Colleague 3 suggests connecting the model to the company's verified financial data sources at query time so that responses are anchored in up-to-date real data rather than generated from the base model alone. Match each colleague's approach to the correct technical term. Option A, colleague 1 equals fine-tuning, colleague 2 equals grounding, colleague 3 equals prompt engineering. Option B, colleague 1 equals prompt engineering, colleague 2 equals fine-tuning, colleague 3 equals grounding. Option C, colleague 1 equals grounding, colleague 2 equals prompt engineering, colleague 3 equals fine-tuning. Option D, colleague 1 equals fine-tuning, colleague 2 equals prompt engineering, colleague 3 equals grounding. Think carefully about what distinguishes these 3 approaches from one another. The correct answer is B. Colleague 1 is describing prompt engineering, which is the practice of crafting detailed, specific input instructions to guide model behavior without altering the model itself. No training or external data connection is involved. Colleague 2 is describing fine-tuning, which involves updating the model's internal weights by training it further on domain-specific data, internalizing that knowledge into the model itself. Colleague 3 is describing grounding, also known as retrieval-augmented generation, which connects the model to external verified data sources at query time so responses are based on real, current information rather than solely on the model's parametric knowledge. The exam frequently tests these 3 terms because they sound related but represent fundamentally different intervention points. Key trigger: crafting the input without changing the model equals prompt engineering. Retraining the model on your own data equals fine-tuning. Connecting the model to external verified data at query time equals grounding. Question 10 of 10. The trickiest question in the set. This question contains 6 deliberate exam-style pivot traps. A national energy regulator is building an artificial intelligence platform. Read each of the 6 requirements carefully and identify any traps before selecting your answer. Requirement 1. A model must predict the exact megawatt output of wind farms for each hour of the next 48 hours based on weather forecast data. Requirement 2. Classify whether incoming maintenance reports from field engineers are routine, urgent, or critical, using a model trained on 10,000 historically labeled reports. Requirement 3. Automatically translate maintenance reports submitted in Welsh and Gaelic into English before processing. Reports are submitted as typed text, not audio. Requirement 4. Screen all images uploaded by field engineers showing equipment damage to detect whether any images contain graphic injury content before the images are stored in the system. Requirement 5. A compliance audit finds that when the regulator's artificial intelligence energy allocation model disadvantages a local community, that community has no route to understand or challenge the decision. The audit also finds that when errors occur, the regulator states the AI vendor, not the regulator, bears responsibility. 2 responsible AI principles are at risk. Name them. Requirement 6. A voice-activated assistant on engineer tablets must transcribe spoken maintenance notes in real time. Which answer correctly addresses all 6 requirements? Option A. Regression model for requirement 1. Text classification for requirement 2. Azure Translator for requirement 3. Azure AI Content Safety for requirement 4. Transparency and accountability for requirement 5, and Azure AI speech-to-text for requirement 6. Option B. Classification model for requirement 1. Sentiment analysis for requirement 2. Azure AI speech for requirement 3. Azure AI vision for requirement 4. Fairness and transparency for requirement 5, and Azure Translator for requirement 6. Option C. Regression model for requirement 1. Text classification for requirement 2. Azure AI speech for requirement 3. Azure AI content safety for requirement 4. Transparency and accountability for requirement 5, and Azure Translator for requirement 6. Option D. Regression model for requirement 1. Named entity recognition for requirement 2. Azure Translator for requirement 3. Azure AI vision for requirement 4. Accountability and inclusiveness for requirement 5, and Azure AI speech for requirement 6. Now here is where each option places its traps. Let's work through every requirement. Requirement 1 asks for an exact megawatt value per hour, which is a continuous numerical output on a scale. That is regression. Option B assigns classification, which is the first trap. Requirement 2 asks for categorization into routine, urgent, or critical using a labeled training set. That is text classification, not sentiment analysis, which only returns positive, negative, or neutral. Options B and D both get this wrong. Requirement 3 specifies that reports are typed text, not audio. Written text translation across languages is the job of Azure Translator, not Azure AI Speech. Option C makes this mistake by assigning Azure AI Speech to a written text translation requirement. Option A correctly assigns Azure Translator. Requirement 4 asks for screening images to detect graphic injury content before storage. That is Azure AI Content Safety, which is built for harm category detection. Azure AI Vision describes image content, but is not the dedicated harmful content screening service. Options B and D get this wrong. Requirement 5 has 2 violations. The community cannot understand or challenge the decision, which is a transparency violation. The regulator blames the vendor, which is an accountability violation. Options B and D each misidentify at least one of these. Requirement 6 involves spoken maintenance, notes being transcribed in real time, which is audio to text conversion. That is Azure AI speech to text. Option C incorrectly assigns Azure Translator, which handles written text, not audio. The correct answer is therefore A. It correctly assigns regression, text classification, Azure Translator, content safety, transparency and accountability, and Azure AI speech. Every other option fails on at least 2 requirements. The master rule for this question and for the exam is to identify the input format and output format of each requirement before naming the service. Written text in, written text out in another language equals translator. Spoken audio in, written text out equals speech service. Numbers from a fixed set equal classification. A number on a continuous scale equals regression. Harm category detection in images equals content safety. Cannot explain decision equals transparency. Blaming vendor for own system equals accountability. How many pivots did you catch before looking at the options? That is the real score from this part. If you are spotting the trap before reading the answer choices, you are genuinely ready for the exam. Post your score out of 10 below. Now, Part 10 is the finale of the series, and it is different from everything that came before it. 10 questions, 15 minutes on the clock, full AI-900 scope, every domain in play. No explanations while you answer, just the questions. At the end, we go through every answer and every pivot. If you have done the work across parts 1 through 9, Part 10 will feel manageable. If there are still gaps, Part 10 will find them in time for you to address them before your exam. Subscribe now. The countdown is on your screen. The final part is coming. I will see you there.